transpose. Okay. 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 Yeah. Okay. Okay. No problem. We'll visit that before. Let me see that of faith first. Then I'll proceed. I'll show you my screen. Then we'll go ahead. Yeah. So Faith, are you ready? Hello, Faith. Okay, yes, we can see it. Yeah, we can see it. Just do whereby. Okay. Yes, that is nice. Enlarge it. Yeah, good. Okay. No problem. You understand your variable names. Uh-huh. Yeah. Mm-hmm. That's all. So it's giving me issues. Uh, mm-hmm. Okay. Yeah, you tried. Tried. That is nice. Okay. Yeah. Okay. It's nice. It's nice. I will show you my screen now. Let me show you what I did. Um, okay. Okay. This was the assignment. I guess you can see my screen now. Can you see my screen? Okay. This was the assignment. We all did well by getting our matrices a lot, but you can observe and see that Y and Z, they are a vector. It's a vector. It's not a matrix. It has just one dimension. Good. So, and if we can't use it for matrix multiplication, we have to make it a two-dimensional matrix by reshaping for it to come. That was why one of the reasons why you were getting that error. So after importing our matrices, then the first we're told to get AB, which is A multiplied by B, or the dot product of A and B, or B and A. So this is what we got. Then the second is also the dot product of B and A and the transpose of B. Now I can just do dot T for my transpose, or I can actually do B dot transpose as Faith was doing it. In number, you can do things in, I think, more than one way, but you always have the same answer. So this gave us the product of A and B transpose. Okay, then on the other part, we have the product of A and Y. If you try to do A and Y, A dot Y, A multiplied by Y directly, you might have an error. So we have to do A dot Y, the dot product. The dot product of A and Y. Now when you see this, the last one, we're talking about this Z, and the dots is different when we try to do the inner or outer. The mathematical concepts, I am not a mathematician, I don't understand, I can't say detail about it mathematically, but I know that this dot product, because of the shape of the matrices, is giving us a different answer from the inner product. So that is it. It's more of mathematics, but having the knowledge that you can do it with NumPy makes it funny and easier. That is it. But our main focus today is more of computer science and more of data analysis, which is we are starting with Pandas. So the NumPy, the reason why we looked at NumPy was to get some understanding of those methods and functions in Pandas that in NumPy that Pandas inherited. Are we together? Okay, so for today, we'll just look at, I'll share this file to you later. We'll just look at Pandas. Like I said, day one, I said Pandas is built on NumPy. So the methods and functions you have in Pandas, in NumPy, they are also being used in Pandas. The difference between Pandas and NumPy is that with Pandas, you can do string, you can have string in your arrays. But in NumPy, you don't have strings in your array. You only have, it's a numeric library. It's pure for numeric. But in Pandas, you can have numeric and non-numeric non-numeric values in your string, in your array, and you perform calculations with that. So first we'll look at, let me just do this. Pandas intro. So like normal, we do our imports Pandas, and the conversion is as PD. We import Pandas as PD. Then the first thing we'll learn how to create a data frame. Now, when we create a data frame, is different from when we are creating a matrix. But we can use NumPy array to create our data frame. We can use NumPy array to create our data frame. A data frame is just simply what we see as a regular table. What we have as a regular table, or what we have as Excel sheets. That's what you can see as a data frame. Okay, so we'll be creating a data frame from a list, and we'll be creating a data frame from a dictionary. We'll be creating a data frame from a list and a data frame from a dictionary. So we'll look at creating a data frame. Before we go to creating a data frame, let's have something. Let me come up with a whiteboard. I will draw something like a tabular data, and we'll try to create that exactly with Pandas. So I guess you can see my whiteboard. Please confirm if you can see my whiteboard. Okay. So let it load up. Let's say we have serial number SN, then also we have let me say names, and we have age. Okay, so we have let me use sex or gender. Gender. Okay, we have this as tabular data. Let me take my pen and draw this. Good. Sorry, the lines might not be straight, just to give us an idea. Okay, when we have these different lines, we should note that a tabular data is also what they call a structured data. A tabular data is a structured data. Okay, now if we have something like this, and we have different values here, this is 1, we have 2, and we have 3. We have these things. Then here again we have the different names. Let me say A. This is a name. Let me just say this is another name, and this is another name. Okay, this is age 12. This is age 41, and this is age 15. This is age 15. So this is, let me say this is a male, this is a female, and this is a female. Let me give priority to women, so that it not look as if I am gender biased. Okay, we have this like this. I want to create a data frame this way. I want to create this data frame. So I go back to my pandas, to my notebook, sorry, and I will create a list. I can create a list. Let me say, okay, let me call this a data equal to the first name I have there is A, right? The first name I have there is A. Sorry, I have A. I have A is, let me say, 12 is age 12 and is a male. That is the first rule. Okay, so since I want to put everything together, I have to put it in double block brackets. Then the second, I have B, and B is age 14 and B is a female. Then the third, okay, B is 41, thank you. 41. And the third is C. C is what, please? 15. C is 15. And the sex is female. I'm using a wrong bracket here. That should be block bracket, not a curly bracket. Okay, I have this as my data. I can create this. This is my data. Then I have the data frame. Most times it's used DF for data frame. It goes to pandas, PD dot, please, the data frame is capital in pandas. Data frame. Then we specify our data, which is this. Now, if we specify our data this way, I will use Shift Enter or call out DF. It gives us the data frame. But we should note that the columns header is giving us 0, 1, 2 because we did not specify our columns. So in this place, we can also specify columns. We can specify columns, which is what columns. Our columns can be specified, and we specify it in a list. The first is name, followed by age, then the last we have gender. So when we run this now, you see it has taken that shape. This is one of the ways we can create a data frame. What you see by the right hand side, the far left, that's 0, 1, 2, is what we call the index of the data frame. Is this clear? Are we clear with this? Okay. Then another alternative way we can create a data frame is using a dictionary. We know what a dictionary is in Python. A dictionary, key value mapping. So I can have this data, let me say data 2 equal to, I'll create this as a dictionary. In this dictionary, I will specify the column names. The column header will be specified. So I have it as name. Then I have the value. I'll put the value as a list. And it will be all the names I want here, which is A, B, C. That is one. Then I go to the next, which is what? Which is age. I put all the ages here. I put all the ages in the list, which is 12, 41, 15. Then finally, I go to the next, which is gender. Then I'll specify all the genders in the list, which is male, female, and female. So with this, I've got my data 2. I can just do df2 at a go. It's got to pd pandas.data frame, which is data 2. So I can call my data frame to be printed for me at once. I do this, I have this. So now, which is quicker? Is it quicker to use a dictionary or is it quicker to use a list to create a data frame? Is it easier to use a list or is it easier to use a dictionary to create a data frame. Yes, dictionary is easier, very easier. And you have other ways to create a data frame, but we'll be doing that tomorrow, where we'll be reading from an Excel file or a CSV file. We can read from an Excel file, we can read from a CSV file to create a data frame. As you already have it in a file, your source of data, you just have to read it, or you downloaded your data set, you just have to read it into your Pandas notebook and you proceed with it. So as from tomorrow, we'll be working with big data, with data sets. But today we'll just do some intro on this. Okay, now we have this our data frame, and I would like to make this to be more meaningful. Let me call this Amina. Amina. Okay, let me call this Timothy. Sorry, I'll change the sex. Timothy. So let me assume that in the class this is Kelvin. We also have another which is Anita. We have another which is Chioma. Okay, the ages, I'll just add 2 age. Okay, let me say this. Then the gender, the first is female. The first is female. Then male. Okay. Then okay, I think that is all. So let me just do this. Okay. Now from like indexing in NumPy, we can actually do our indexing in Pandas. Let's assume I want to extract the information. I want only the names and the gender to show. What I have to do is I'll just do df. If I do df names, it will show only the names. And this is giving me a series, not a data frame. So if I want the name and the gender, then I have to specify this. This have to be I have to do this, or the other is gender. But take note, the square bracket has to be double, not just one square bracket. The concept is that you are passing a list inside the index. So when you do this, you have your main and df2. I'm working with df2. Then you get what you want, the names and the gender. You get the names and the gender. Now, some might say, okay, this is just getting the column wise, but you want to get the row wise, the row structure. You want to get a particular row, or you want to get some rows. If you want to get a row, we use what we call the lock, LOC. Either use the LOC method or use the iLock method. I'll tell you the difference between the two. So I'll say df2 dot iLock, then I'll have my square brackets. If I say iLock 1, if I do this, you see it gives me what belongs to Timothy. It gives me what belongs to Timothy, everything that belongs to Timothy, just what is given me. But if I say give me iLock 1, 2, I want 4, good, then you see it gives me from 1, 2, 3. Now you see the difference between the iLock and the lock. Now if I do df2 dot lock, I said okay, give me 1 to 4. The the difference is the fourth column or the fourth row, sorry, will be included. The fourth row will be included, but the other ILOG will not include the fourth one. It will stop before the fourth row. That is for that ILOG. I don't know if you understand the difference now. Okay. The difference between ILOG and log is that when you are indexing, you want a series of rows. So if you use ILOG stop before that last number, before the place you ask it to solve. Like when you are doing your range, if you say range 0, if you say range 0, 4, it will give you 0, 1, 2, 3. But if you say range 0, 5, it will give you 0, 1, 2, 3, 4, 5. So ILOG works like range, but log works differently because it includes the stopping number. It includes the stopping number. Why ILOG stops before the stopping number? As you can see it from the screen now. So that's how we can get the row of the data frame. So we can use the column headers to get the head, and we can use the indexes to get the row of the data frame. Now let's assume we want to perform another operation. We want to drop, as we want to remove a particular row, or we want to remove a particular column from the data frame. Let me assume first I want to drop the H column. I want to drop the H column. I don't want to make use of the H column. So what I have to do, I'll do here df2 dot drop. Then I open my brackets. I'll specify what I want, which is the H. There's something important I have to specify. I have to specify the axis. Remember when we're doing concatenation in NumPy, we always specify the axis, and we specify our axis 0 being what? Being row, y1 being column. If I not specify the axis, I'm likely to get an error. It will tell me that axis not found. Axis not found, because the default it gives us 0. So all I have to do here is to add an axis. I can use axis here or equal to 1, since it is a column. When I do this, it will give me my results. Or I can equally just forget about the axis and just have my 1. It also works, but it gives me a warning that in the future this might likely cause a problem. So that's why we always specify the axis using the axis index. Using the axis equal to 1. So it goes towards the row, towards the column, and look at the column. Anyone that have the column age, it drops it out, it takes it out. This is one way we can drop. a column. Another way we can drop a column or perform drop, either a column or a row, is by using the keyword in place. When we use the keyword in place, we don't need to assign the data frame. We don't need to reassign the data frame. Like you see this, I have dropped this. If I come below and say df2, it takes no effect in what I dropped. I still see my age. But if I should specify the keyword here, the positional keyword in place, if I specify the positional keyword in place and I put it as true, I place it as true, then it will go straight. I don't need to reassign. Okay, so we'll do that and we'll see the effects. First and foremost, before I do that, I would like to assign to keep this my column in a place, my age column in a place. So I'll call this age, or let me call it ages, equal to the F2 age. So I've stored this in a place. When I go for my ages, it prints for me just like what I stored. Okay, so now I can repeat this same command. Knowing fully well that after we did this and we did the F2, it gave us the same original data frame with the age column still in it. So our dropping did not take place in the original. So if we want it to take place in the original, what we have to do is we just have to do this. Then we'll specify the keyword in place equals to true. Once we specify this keyword in place equals to true, and we run this, we do our df2, you find out that df2 has changed because the in place equal to 2 affects the original state of the data frame. I don't know if you understand. Yes, sir. Yes. Yeah, you can no longer reference the original data set is not in the same way. Yes, because if as I reference df2, I find out that it has changed. That is in cell 26. But when I reference df2 in cell 24 at this particular place 24, you find out that it still brought out the age. So when you do not specify in place, it does not affect the original. But when you specify in place, it affects the original. Okay, yeah. So now since we've dropped, yes, yeah, I can hear you. Exactly.